Hi, I'm Justin Jennifer. We are discussing Flutter topics or Flutter interview questions. Today we will discuss about the object-oriented concepts used in Dart or Flutter and give real-world example for each of them. Stay with us till the end to completely grab the concepts. The first one is encapsulation. Encapsulation in Dart refers to the bundling of data and methods that operate on the data into a single unit known as a class. This concept restricts access to some of the object components, providing control over how the data is accessed and modified. Encapsulation helps in maintaining the integrity of the data by preventing direct access from outside the class. Here is an example demonstrating encapsulation in Dart. Define a class representing a bank account. Class bank account private variables to store account details in account number double balance. Constructor to initialize account details bank account this account number this balance. Method to deposit money into the account void deposit double amount if amount greater than zero balance plus equals amount print dollar amount deposited successfully else print invalid amount. A method to withdraw money from the account void withdraw double amount if amount greater than zero and an amount less than equals balance equals amount print dollar amount withdrawn successfully else print sufficient funds. The method to display account details void display account info or print account number dollar account number print balance dollar balance a void main create an instance of bank account account equals bank account 123,456,789 1000. Call methods on the account object account deposit 500 account withdrawn 200 account display account info. In the provided code, encapsulation works by defining the bank account class with private instance variables account number and balance and providing public methods deposit, withdraw, and display account info to interact with these variables. Let's break down how encapsulation is implemented. 1. Private variables. The account number and balance variables are marked as private by prefixing them with an underscore. This means they can only be accessed within the bank account class itself and are not directly accessible from outside the class. 2. Constructor initialization. The constructor bank account takes initial values for account number and balance as parameters and initializes them. Since these variables are private, their values can only be set within the class, ensuring that their integrity is maintained. 3. Public methods. Public methods like deposit, withdraw, and display account info provide controlled access to the private variables. These methods allow external code to interact with the bank account object in a controlled manner, ensuring that the internal state of the object is not compromised. 4. Method validation. Within the deposit and withdraw methods, there are checks to ensure that the deposited or withdrawn amount is valid and that the balance is updated accordingly. This validation ensures that the internal state of the bank account object remains consistent. 5. Data hiding. By encapsulating the account details, account number, and balance within the bank account class and making them private, we hide th. The internal implementation details of the class from the outside world. External code can only interact with the object through the provided public methods, preventing direct manipulation of the internal data. 6. Controlled access. Encapsulation allows us to control how the data is accessed and modified. External code can only access the private variables indirectly through the public methods, ensuring that any modifications to the object's state follow the rules defined within the class. Overall, encapsulation in this code ensures data integrity, enhances code maintainability, and promotes code reusability by hiding the internal implementation details and exposing only the necessary functionalities through well-defined interfaces. That all the possible explanation of encapsulation. The second main concept is polymorphism. Poly mean many and morphism mean form, many form. Polymorphism in Dart refers to the ability of different objects to respond to the same message or method invocation in different ways. Dart supports two types of polymorphism: compile-time polymorphism achieved through method overloading and operator overloading, and runtime polymorphism achieved through inheritance and method overriding. Here's an example demonstrating runtime polymorphism in Dart. Define a superclass class animal void makes sound, print animal makes a sound. Define a subclass that overrides the make sound method class dog extends animal it override. Void makes sound, print dog barks. Define another subclass that also overrides the make sound method class cat extends animal it override. Void makes sound, print cat meows. A void main create instances of both subclasses. Animal dog equals dog. Animal cat equals cat. Call the make sound method on both instances. Dog makes sound. This print dog barks, cat makes sound. This print cat meows in the provided code. Polymorphism is demonstrated through method overriding, a form of runtime polymorphism. Let's break down how it works. One superclass definition. Animal. We define a superclass called animal. This class has a method makes sound that prints a generic message indicating an animal makes a sound. Two subclass definitions, dog and cat. We define two subclasses, dog and cat, which both extend the animal superclass. Each subclass overrides the make sound method with its own implementation. In dog, make sound prints dog barks. In cat, make sound prints cat meows. 3. Object creation and polymorphic behavior main function. In the main function, we create instances of both dog and cat classes and assign them to variables of type animal. This is possible because Dart allows objects of subclasses to be treated as objects of their superclass. When we call the makeSound method on these instances, Dart dynamically dispatches the call to the appropriate method based on the actual type of object at runtime. Despite the method being called on objects of type animal, the overridden method in the subclass dog or cat is executed. This behavior demonstrates runtime polymorphism, where the behavior of the method call is determined by the actual type of the object at runtime. That is all about polymorphism. Here I am trying to explain each concept with short example. I am hoping that you are getting my point. If you any confusion regarding these topics or want to make separate videos on these topics, let me know in the comment section. I suggest you must watch 2 to 3 times and practice the example by yourself. Then you will grab the concept very well. Okay, let's move on to the new concept of object-oriented programming concepts used in Dart or Flutter. The next one is the inheritance. Inheritance. Inheritance is a fundamental concept in object programming that allows a class to inherit properties and methods from another class. In Dart, a class can inherit from another class using the extends keyword. Consider the following example. We have parent class called animal with member variable name. We have speak method which print animal speaks. A child class or subclass called dog extends animal, which a member called breed. In this example, we have two classes, animal and dog. The dog class extends the animal class using the extends keyword. This means that the dog class inherits all properties and methods from the animal class. In the dog class, we've added a new property, breed. The dog class constructor takes both name and breed parameters. We call the superclass constructor supername to initialize the name property inherited from the animal class. Additionally, we override the speak method in the dog class. This means that when we call speak on a dog object, it will execute the overridden method defined in the dog class rather than the one defined in the animal class. In the main function, we create an instance of the dog class and access its properties, name and breed, as well as invoke its overridden speak method. Hope you got the concept. Let's move to the next concept. The fourth one is the abstraction. Abstraction in Flutter involves defining classes with abstract methods or properties which are meant to be implemented by subclasses. This allows for a higher level of generalization while leaving specific details to be implemented by concrete subclasses. Here's an example demonstrating abstraction in Flutter. First of all, define an abstract class called shape. Abstract class shape, declare an abstract method named calculateria. Double calculateria. Define a class called rectangle that extends shape. Class rectangle extends shape. Declare properties for length and width of the rectangle. Double length, double width, constructor for rectangle class. Rectangle this length, this width. Override the calculateria method for rectangle. And override. Double calculateria, calculate and return the area of the rectangle. Return length asterisk width. And now in the main function void main, create an instance of rectangle with length 5 and width 3. Var rectangle equals rectangle 5, 3. This print the area of the rectangle. Print area of the rectangle, $rectangle, calculate area. In the provided code example, abstraction is demonstrated through the use of an abstract class shape and its concrete subclass rectangle. Here's how abstraction works in this context. 1. Abstract. Class shape. The shape class is declared as abstract using the abstract keyword. This means that it cannot be instantiated directly. Inside the abstract class, an abstract method calculateria is declared. This method doesn't have an implementation and is meant to be implemented by subclasses. To concrete subclass rectangle, the rectangle class extends the abstract class shape. By extending shape, rectangle inherits the abstract method calculateria. The rectangle class defines its specific properties, length and width, which represent the dimensions of the rectangle. A constructor is defined to initialize the length and width properties when creating a rectangle object. The calculate area method is overridden in the rectangle class to provide a specific implementation for calculating the area of a rectangle, which is length asterisk width. 3. Utilization. In the main function, an instance of rectangle is created with specific dimensions length 5, width 3. Even though rectangle is a subclass of shape, we interact with it directly, calling its calculate area method without needing to know its specific implementation details. This demonstrates the concept of abstraction, where we work with a generalization shape without needing to understand the specific details of its subclass's rectangle in this case. In summary, abstraction in this context allows us to define a common interface shape with abstract methods, leaving the specific implementations to its subclass's rectangle. This promotes code reusability, modularity, and flexibility as new shapes can be easily added by creating additional subclasses of shape and implementing the required methods, that all possible explanation about abstraction and that all about the object-oriented concept in Dart or Flutter. If this video helped you, give it a like, subscribe to the channel for more contents, press the bell icon for future updates, and ask your question in comment section.